Mathematics, anyone? Welcome to Precalculus class. Today I will teach you this topic. It's a trigonometric form of a complex number. My class is in two sections. The first part of my class is about how to find the modulus and argument of a complex number. Okay. The second part of my class will be about how to convert complex number from regular to polar form. Okay, from regular to polar form. Okay, those sections for today. All right, this is first section. I will show you some problems to show you what I mean the trigonometric formula or a complex number. So I will erase this little topic. How this is a first part. Find the modulus or argument of the complex number. Okay. So in this section, let me write one problem. I will write one problem to show you what I mean this. Okay. So our first problem will be about how find find the modulus. Let's see. Find the modulus. The modules are, let's say the variable are an argument okay, an argument of this angle of z. Okay, I will write the graph right here. So for our problem. Okay, the graph is this. Let me use a different color. Let's write let me write this little graph right here. Okay, this is my graph, and then also let's write here on top. Let me write the numbers. On top we write imaginary right here. Or this imaginary axis. Okay, axis. And this one and the horizontal one we call the real axis. Real. Okay, so some points. Then let's write some points here to show you. It's a 2, 4, 5, 6, 10. So each one is going to be 2. I mean 2 here, 2i, 4i, 6i, and 8i, and 10i. Okay. So imaginary axis and the real axis. And then our problem is going to be right here. So this find the modulus are an argument of this point. The point will be right here. Right there is the point z. Okay, z. That's our problem right there. Okay, we have to find the modulus of this point. The point point R is right there, and then the argument of angle z. So that's the problem. We have to simplify here. Simplify all radials and fractions. We have to simplify all radians and fractions. So simplify here. Find all radians and fractions. Okay, and express the argument in radians. So express express the argument. We are looking for the argument in radians. Okay, in radians with let's see with let's write 0 less or equals than this angle, right? The angle and then less than 2 pi. Less than 2 pi. Actually, that's our problem. So I will write the problem here, right? Because I will erase this. So write 0 less or equals than this angle, and then less than 2 pi. Okay, see? So we have to find r and then the angle. All right. We have to know how much is r. R equals, and then also the angle, right here. I went in that corner for the answer. So here in this case, the main idea of our class today, we have to know what I mean the modulus or absolute value. So that's what we call here modulus. Modulus or absolute value, or okay, we need to know what I mean this, and then absolute value of I mean r, absolute value r over the complex number. What is the complex number? The complex number we used to write in this way, okay? Just for remember you, a plus bi. Remember, this is a complex number. In the distance, so in the distance right here, you have in the distance between the origin is right here, and the point. And the point, I mean this point is called a plus bi. A plus bi. All right, in the complex plane. In the complex plane. I mean, we have to some good idea here. R is will be equals r. Then so a plus bi, okay, absolute value. That is what I told you, equals square root, okay, this is a very important formula, square root of a to the second power plus b to the second power. All right, that's the main idea of the modulus, okay, or absolute value. So then we have another part, modulus here. The second part, the second concept, main idea here is the argument. What I mean the argument? Okay, what I mean that. See, let's see. Let me erase it here. Right? Take a look at this. If you wanna see what is going on here, just look my video back. Okay, play the video back, and then you see this. This is very important. Okay, what I mean, r, the distance right here in the graph. So the next point, we are talking about the argument. Okay, here argument. Okay, the argument is about the argument when we talk about the angle. The argument, just write it like argument of the non-zero, in this case non-zero complex number. So this means non-zero complex number. I mean the number is non-zero complex number. Complex number is a plus bi. It's non-zero complex number a plus bi. Okay. This is the counter. We have to move, when you move it, to know it's a counter. We have to move counter clock like this. Let me write it. Counter clock wise. It's one word. Counterclockwise. I mean, you have to move in this way, in the graph. Okay. Now to the left, right? To the left, and go from the positive, from the positive real axis. This is the positive here, positive real axis. This is negative real axis. This is negative imaginary axis. Okay, we have to move from the positive real axis then to the segment between the origin and the point AB. I mean, the point AB is the argument. So argument are usually chosen to be between 0 and the argument is actually not all the argument is actually chosen between 0 and 2 pi. This is a very important idea. So when a distance, when a is equal 0, when a, for example, the point is b. I mean, the point a plus bi, the point a, on the imaginary axis, and on the imaginary axis, and the angle is, I mean, let me write right here, imaginary axis, and the how called, and the angle, let me write this angle, the angle here, this angle we are talking about, the same angle is here. Look at this, is it is pi divided by 2, or 3 pi divided by 2. So why? I will erase this. I'm talking about the concept. Right now I'm not solving the problem, just the concept. What I mean, and the modulus, the first part, and then right now I am talking about the argument. What I mean, the argument. Okay, when you try to find the argument, so all these ideas you need to know. All right. So here, when is the when a is a different 0 to 0, when a is for instance different to 0, the angle satisfies this thing, tan of angle here is equals b divided by a. Okay. Let me show you in the graph. It's easier, I mean, it's better when you have a graph. For instance, this little graph here. This called this imaginary axis. Here is imaginary axis. All right, and then this is a real axis. I'm explaining the main idea of my class today. Still we are in the concept. I not solved yet my problem. So we have this graph here. Then the graph is running like this. Okay, this is my graph. I have this point right here. Another point right here. We call this point, look at this, because we are talking about, I am talking about the A and BI. Here this point is BI here, and then also this point is A. We call A. And then my graph is running in this way. Let's see, let's make this little point right here. All right, that is too much. It's too much. It is too much right here. How I point here? This graph, look at this, is running this way. All right, to there. Now here, and this point is here is a plus bi. All right, you got it. And then in this line we call r. I mean the absolute or the modulus. We remember the first part. This is the r or the absolute value. And this is the angle which I am talking about. This is the angle, right? See, got it now. And so it is very important when you see the graph. I think this is easier to understand the concept modulus and argument. Everything is in this graph. Okay, so let's erase this. Okay. So now let's go to the point A plus B. Has a here point A plus B I has a rectangular coordinates. Okay. You saw in the graph, right? I mean, those coordinates A, comma B in the graph, right? Which I make a picture right here, right? And then it has a polar coordinates. It has, because we are talking about the polar coordinates. It has we call polar. Yeah, polar. This is very look at this polar coordinates. Which are here is polar coordinates is r and the angle. Okay, so it's different here. This is a rectangular coordinates is AB. The polar coordinates is r and the angle. I already make the picture here. So the complex numbers are usually written in rectangular form in this way, rectangular form. Okay, I mean it's A plus B. In the rectangular form is A plus BA. Okay, the polar form or trigonometric form is other way, or trigonometric. Remember, trigonometric form. Okay, which is our topic today, trigonometric form of A plus BI plus BI is look this, which is going to be our final class. Is R. We have to write R. Look at this R. Open curtail right here R, and then inside we have to write cosine of the angle which are talking about, this angle. See, and then plus I mean imaginaries sine of the angle. Okay, then close. This is a very important thing here. The polar or the trigonometric trigonometric form of A plus BI is this little formula. Okay, keeping in mind this, and then now let's look for the solution of the problem. The problem today is very simple. It is easy problem. It is not hard. So you need to review this little concept to see how apply, how work it in the solution of our problem. So we have to solve now our problem. All right. So we have the point. Very important thing. What is the point there? We have first point. So some information here. We have the point. The point is 0, 7, right? 2, 4, 6, 7, right? It's in the middle between 6 and 8. So the point is 0, 7. That's the point that we are talking about. These points represent the complex number. These points represent the complex number. So how represent the complex number here? Is 0, 0 plus 7 plus 7i, because it's imaginary. 0 plus 7, which is equals 7i, right? Main point right here. We are talking about this graph. Look at the graph there. Then in the complex plane, this is the plane. So in the complex plane, all right. So the rectangular form of the given number z is another thing we are talking about. The rectangular is another important thing. The rectangular form. We are talking about trigonometric form and the rectangular form. It's a little different of the given numbers. This, in this case, of the given numbers z, the z, c here, this is a given number. And right here, the given number z. See, z right there. Look at the point. Z is 7i. Okay, 7i right there. Okay, that's another thing. So now find r. We have to find r. Look at this. To here, I will erase this. This is already solved our problem here. The point is 0, 7. The complex number is 0 plus 7i right here in the imaginary plane. So now the rectangular form z is 7i. We are looking for, okay, right? Z and r. All right. So let's go next step. Okay. So now find r. So z, we have to find r. Find r. Here is another main point. Find r. We have to find r. Is the distance between the origin and the point 7. Let me. Yeah, maybe I need to. Is the distance here between between the origin, between the origin, yeah, the origin and the point 7i. As the distance 7i, imaginary, 7 imaginary number. Okay, so in the complex plane, of course, we are talking about in the complex plane. You have the complex plane right here. So this point maybe is right there. Yeah, I will write the number right here. Here is 7i. 7i right here. The r is 7r. Okay, I don't want to make another graph. So now we have to find this is R is 7I. Okay, now the angle, find the angle. So it's find the modulus R and the argument here, argument of the angle. The argument here is when you find this angle is argument argument of this angle is the counter clock. Remember, is the I already told you the counter clock. Oh no, counter clockwise, right? I mean, in this way you move the counter clock. Angle 4 here, angle 4 here, angle 4. See, I already write the main concept. So let me I will erase all this because I wanna show you in the graph what I mean the counterclockwise. What I mean this. Okay, I will erase all this. So keep in mind this 7I, and then how find the angle. I mean the argument of angle is the counterclockwise. So 4. Let me show you how work this. If you have a graph like this graph, I'm gonna make in this little space my graph. This is my graph. Okay, and then I will divide my graph, and then by sections, right? We have divided the same thing. 2, 4, 5, 2, 4, 6, 8, 10, whatever, like that. Yeah, 1, 2, 3, 4, 5. Okay, and then this is my little graph. This look at this. I will show you in this graph how work this part or how find the angle. So for instance, we have like this, the circles. I don't have a rule, but so like this, like this. Okay, so like that. Then I will divide my graph and this part. For instance, like that. So you must use the rule. You use the rule. You must to have exactly the division. Okay, like something like this. But use the rule is very equals. I mean equals. Here is not equals, but I try to show you what I mean this. So in this case, I will write the numbers here. So this is pi divided by 6, and this line. This another line is pi divided by 3. And here, and this is pi. Here is pi divided by 2. Pi divided by 2. Okay. Here is 3 pi divided by here, and the bottom one is divided by 2. Here, and this line is equals 2 pi divided by 3. Okay, this line is 5 pi divided by 6, and this of course is only pi. Here this is 7 pi divided by here divided by 3, and here is 4 pi divided by 3 divided by 3. Okay, this one is 6 is 6, and then also here is 5 divided by pi divided by 5 pi divided by 6, and then here is 11 pi divided by 6. Here is 3. 5 pi divided by 3. This is 11 pi divided by 6, and here is 0. All right, you see all numbers right there. Now look at the graph. Now the terminal side of the angle, this angle is along the positive imaginary axis. Positive imaginary axis right here. Positive imaginary axis. So so why the terminal sides of this angle, the terminal, because remember it's over imaginary axis, so it's not this one. It is let me write it. It's equals pi here, pi divided by 2. It's right here over this is pi divided by 2. Okay, that's the size of the angle, right? You're looking for. You see why? Why? Because the point is right here. Where is the point? Well, mark that point. Remember this point. It's the same graph. I did this graph. It's 2 right here. 2. Let me write. Because maybe you why is a pi divided by 2? Because you have 2i here, 4i here, 6i here. It doesn't matter, but the point is right here. This is our point right here. Where is the point then? Right here. That's the point. That point is in the imaginary axis. This is imaginary. This one is imaginary axis. This is the real axis. This one is the same graph over there, but I make another picture right here to see why is this angle is pi divided by 2, because it's in the positive. It's in the positive, right? Imaginary axis. This is the negative. This is positive. This is positive real axis. This is negative real axis. Okay. All right. Let's erase it here. So I already told you why and how find this solution here. Okay. So next, complete the polar form. Next one, complete. So 8, complete form. Complete the polar form. All right, the polar form of Z. It's the same problem. All right, we're talking about polar form Z, or of C. Polar form of C. Of C. Okay. Let me make another graph right here to show you what I mean this. The polar form of Z. All right. We have my graph like this. So it's 2, 4, 6, 8, and 10. It's negative 2i, negative 4i, negative 6i, and negative 8i, and then negative 10i. Okay. So we have this the admin. And this part, let me reset this. Maybe I need to start. It's the second part of my class. Second part, but it's continuation the this class. But maybe let me reset everything because a lot of words here. Maybe you don't understand this. Let me start over. So to be clear, so we solved the first part. So the second part of my class, actually, let me write it here. Is convert complex number. Is convert. How convert complex number? Okay, from regular form. All right, from regular form to polar form. Okay, to polar form. All right. Actually, this is the second section of the class. We need to be clear, right? Maybe I didn't specify when came to the second section of the class. Right, it's going to be this: convert complex numbers from the regular form to the polar form. All right. So let's write again my continuation of the problem. So the first, we have to complete the polar. I wanna write again. Complete the polar form. Polar form of z. See, let me write the graph. So again, this is my graph. We have this is 2i. This is the same graph that I did. Okay, 4i, 6i, 8i, and 10i. That's my little graph. Okay, so we have to express the argument here. Express, look at this, express the argument of the angle here in radians. Okay, in radians with 0. I already write this number before. 0 less or equals than this angle. Actually, let me write another with a different color. Okay, 0 less or equals than the angle, and then less than 2 pi. Okay, 2 pi. All right, we have this problem here. We have to express in the how express the argument here in radians with 0 less or equals than this angle, and then less or 2 pi. Okay, we have to solve. We have our now. We need to write a point right there. We have the point right here again. 7 is right here. Let's write down this point right here. Look at my point right there. It's Z right here. Our problem. Now it's right there the point. Now it's there the point. Here is 0. Don't lose. That's my problem. Complete the polar form of Z right here. We are talking about that. So how solve this question here? Again, the same thing that before I write it. We are talking about here the point. Here is point. See the point. The point there is 0, negative. I mean minus now. Minus 7. See? The point is negative 7. So represent the complex number. So complex number. Again, what is the complex number here? The complex number is 0 plus negative 7. Negative 7i. Here. Negative 7i is because I'm talking about the complex number. So the answer is negative 7i. Okay? That's the number. So we have to find here now, find r. Find r. How find r? R is the distance between the origin to the point negative 7 right here, negative 7. That's the distance. So what is the distance? So the distance is 7. It's 7. We are talking about only the distance, the absolute value. The distance find r there is 7. So r here is equals 7. See, r is equals 7. Now we have to find the angle right there. The angle is going to be different than the other one. Remember the other one. In this case, is the contra again. Counterclockwise. The counterclockwise. As I mean, we have to make the whole round. The whole round. Start from positive real axis. Okay, positive real axis, and then the segment, the origin, and the point 7 from the segment, the origin of the segment, we have to move to all around to the point. I mean to the segment of the point with which we are talking. I mean the point A plus BI is right here. Then again, let me show you in a graph. Let me show you in the graph. So here, let's continue talking about find this angle. Okay, we're talking about that. We are talking about the counterclock. So if you have here, remember I already made this picture, right? I already did before. So I'm gonna make these circles 1, 2, 3, 4, 5. See, it is the same graph here. This is a real axis, and then this imaginary axis. Okay, is the same thing here. The real, imaginary axis, and the real axis. Okay. Also, we have some those lines right here. Again, right there. So I will write the numbers again, maybe as oh, I don't want to write all numbers right here. So I want to write right here. Is here? Remember this was which one? Right here. Pi divided by 2. That point. This one is pi divided by 6. And here is No, it's not here. Phi is right here. Pi, this one is divided by 6. This one is divided by 3. It's 2 pi. 2 pi divided by 3. Divided by 3, and then this, here is pi. Only pi. Here is 7 pi divided by 6. And then here is 4 pi divided by 3. And then we have here is 3 pi. It's very important here. 3 pi divided by here divided by 2. 3 pi divided by 2, and here this is 5 pi divided by 3. 11 pi divided by 6. Here is 0. Alright, that's it. This is 0 right here. Okay, you have all data, but need to watch in which side we have our problem here. The imaginary complex, or our complex number, is right here. It's right here. Right there. We have our point right here. So then we have to move from where or how, all around here. We need to start, I told you, in the segment. This is origin in the segment of the real axis here. So we have to move from here. The point is right here. We have to move all the way right here. See, started counter close Y. We started to move it right here, all the way, right there. So it's in the middle. This point all the way here. So what is the answer then? How much is this I mean the angle? How much is it? The answer. So the answer is equals 3 here, right here, 3 pi. 3 pi divided by 2. See, got it? It's the answer because it is in this segment. Negative imaginary axis. Negative imaginary axis. Alright, so find the polar form. Now, we have to find the polar form. Ready here? We have to find the polar form. Find the polar form. Find polar form. Okay, so use the values of r and the angle to find the polar form. How to write the polar form right there? We need to find those values first and then write the polar form. The polar form is remember the formula. The formula is r, and then cos. Remember cosine of the angle. See, cosine of the angle plus imaginary sine of the angle. This is my formula. So now this is equals when the information that we have it here is 7 right there. 7 cosine. 7 cosine. Okay, cosine times, remember the solution is the angle. How much is the angle? Is 3 pi divided by 2. See, 3 pi divided by 2 plus the imaginary sine of the 3 pi divided by 2. So that's it. That's the polar form. This is the polar form. So maybe the next part is another complement of these two sections. Let me go something else very important. So when you want to change the number from this form to the regular form, so now let me write number 3 section. It's a complementation. Convert here. Convert complex number numbers or complex convert complex numbers from let's see, from polar to regular form, from polar to regular form. Okay, remember we already did the polar form. So now how change from polar to regular form. Okay, this part. There's like to complement this. Let me write one problem. Write as I want to show you in the problem. Write cosine of pi divided by 2 plus imaginary sine of pi divided by 2. That was our first solution, remember, in the first problem. In regular, that was in regular, in regular form. So this is in polar form, so we have to change to regular form. So how solve this? First of all, the complex number is this one, cosine of pi divided by 2 plus imaginary sine of pi divided by 2 has a modulus 1. Okay, this has a modulus 1. They have, or this polar form has a like modulo 1. Modulus 1. Remember our first part of my class I explained this. That's why I give it to you. What I mean is modulus 1, and the argument, this is complemented. The argument is pi divided by 2. See, pi divided by 2. It's very important. So it has a polar coordinated. It has a polar coordinated. So polar. So the polar coordinated is 1. Okay, 1 pi divided by 2. I'll write it step by step. Okay. So look the graph. Let's see the graph. Look the graph. So I have this graph right here to show you this question. So we have 2, 4, 6, 8, 10. Okay, here in the answer here, right there. Remember that was our first problem. Remember this is pi divided by 2 right there, and this point. Okay, this imaginary axis. Okay, this is the real axis. Okay, again. Okay, so we have to move from one. You have here the graph. Remember the graph right here as we call here 1, and then it's not the same, but suppose it's the same. Okay, this is 1 right here, okay, and this is 1 right here. This is 0. So you have to move right here in this way. See, and the graph. Look this graph. This is imaginary, so move it right there. That's why I'm talking about this polar coordinate. It says 1. It's 1. Okay, it's a modulo 1. Modulo 1. So the point with polar coordinates 1 comma pi divided by 2 represent the imaginary. So these represent the imaginary number. So let's I will erase it here. Okay, just explain it to you. This maybe in the graph is easier to understand. So these points, I mean 1 comma pi divided by 2, these points represent the imaginary. Yeah, the imaginary in the complex plane. Okay, and the complex plane. So as conclusion, so cosine of pi divided by 2, okay, plus imaginary sine of pi divided by 2. Remember, I show you in the graph is imaginary. It's imaginary numbers, right? So you can check, you want to check this, for instance, because maybe, let me write this part and on top right here. You want to check this evaluation, cosine and sine. So check, let me write here, check cosine and sine. So you want to check this solution. You have here, look at this. This is very important. Let's write it, cosine of pi divided by 2 plus imaginary sine of pi divided by 2. Okay, so how solve this problem? So this is equals, here is equals 0, here is 0 plus I times 1. See? So what is the answer then? So you want to check, which is a proof. So this is equals I. Same, right? So that's the solution. So that's it for today. Trigonometric form of a complex number. I show you the complex plane, what I mean, the regular form, the absolute value, the modulus, and the polar form. So different thing in our pre-calculus class today. I hope my class today become very useful in your homework or in some problems that you have in a pre-calculus class. Okay, thank you.